Good morning, good afternoon, good evening. We are back and better than ever. Here we go. We are talking kinematics part 2 here. We are continuing right where we left off. And I believe we left off. Stop that. Undo. Okay, we left off at D. Okay. So, we have a particle moving. Let's see, we found expressions for velocity and for acceleration. We did sign diagrams for both of them. We found the initial conditions. We found the conditions at time equal to 2 seconds. And now we are being asked to find the position of the particle when changes in direction occur. Key word is direction. Well, what tells us direction? Velocity tells us direction. Velocity is a vector. So a change in sign tells us that we have a change in direction. So between 0 and 1 second, the particle or the object is moving to the left. And then right at 1 second, it changes and starts moving to the right. So the change occurs at time t equals to 1. Now they're asking for the position, so we're going to use our position function or displacement function for t equal to 1. So s of 1, replacing t with 1, is going to be equal to -1. So what does that mean? That means that p is 1 centimeter to the left of the origin. Okay, left of the origin. There we go. Okay, so now let's do E. We're running out of space, but I need a lot of this stuff. I'll get rid of some of it if I need to. Okay, E. Draw a motion diagram for the particle. Okay, so let's do a motion diagram. Just need a segment here. Oh no, let's make it, no, it should be a line. Sorry about that, it should be a line. Okay, so we're going to have a line here. What is a motion diagram? Well, a motion diagram shows us all the important points for the motion of the particle. And what are all the points that have come up? Well, time equals 0. Okay. And let's see, we're going to do a -1. And we're going to do, let's see, a 1, a 2, and a 3. And you'll see why in just a second. 3, 2, 1. Okay. So the motion diagram, it's the direction it's going at a particular time. Okay. And so this represents the position. Okay. This line is position. So all of these are the centimeters. Okay. What was the initial position of this particle, particle P? Well, the initial conditions have it starting at 1. So we'll put a point there, okay, starting at 1. Then what happened? Which way was it going? Well, it was moving to the left because of our velocity function. So we're going to start going this way, this way, this way. Then what happened at 1? Well, at 1 it changed direction. And the way we do the motion diagram is we just have it reverse direction. And then it continued this way forever and ever and ever. Okay. And let's see. Draw a motion diagram for the particle. We don't have a constraint, so we'll just keep it going. Do we know anything else? We know its position at 2 is at 3 centimeters, so I can put that on there. I don't have to, but I can. And so we know it looks like this. And to indicate direction, we put a couple more arrowheads on here just to be sure that we know the direction and the overall motion of the particle. So this is a motion diagram for this this particle given this displacement function. Pretty simple. Okay, F. For what time interval is the particle's speed increasing. Huh. Well, speed is increasing. We kind of did that back here in part C. Speed is increasing when velocity and acceleration are the same sign. Well, acceleration is always positive, and velocity is only positive when t is greater than or equal to 1. So when are they positive at the same time? Well, that would be for t greater than or equal to 1 is when the speed is increasing. Okay? What is the total distance traveled in time from t equals 0 to t equals 2 seconds? Okay, so I'm going to give myself some room here. Let me do this. I think I can use my sign diagram. I'm going to get rid of this. Okay. Sorry about the delay. Bam. I don't think I need that to answer question G. Okay, so now question G. What is the total distance traveled in time from t equals 0 to t equals 2 seconds? Okay. Well, this is t equals 2 right here. Don't get this. This represents position, and then this diagram here is position relative to time. So at t equals 2, it traveled 3 meters. So what is the total distance it traveled? Well, it started at 1 and traveled to the left 2 meters. So that would be 2. Yes. And then it traveled to the right. Let's see. At t equals 2, it was at 3 centimeters to the right of the origin. We know that right here because s of 2 is equal to 3. So how far is that? Well, that's 1, 2, 3, 4 centimeters. So 2 plus 4 is going to be equal to 6 centimeters. Okay? So that's all the information we can get, or almost all of the information we can get from a displacement function or a position function. All right, we will talk more next time, and we shall see ya!